Okay, so this next page, I'm going to show you using the same problem, two different methods, long division and synthetic division. And I think what you'll find is you're going to turn out that you're going to love synthetic division. At least I do. I think it's much faster. Okay, so long division is going to look like we've already been working on. Okay, just make sure I get this written down right. Okay, so when you start long division, you're just going to look at these front two terms and you're just asking yourself, what would I have to multiply x by to turn it into 2x to the third? Okay, so that's going to be 2x squared. So when I distribute, that'd be 2x to the third plus 6x squared. And then draw the line, change both of those signs. That's going to be x squared. Then you bring down the next term. And then you look, what would I have to multiply x by to turn it into x squared? That would be x. Oops. So then that's x squared plus 3x. Draw the line, change both of those signs. So now that's going to be 6x. And then you bring down the last thing, and that's a negative 20. What would I have to multiply x by to turn it into 6x? Well, that would just be the 6. So then 6x plus 18. Okay, then we're going to draw the line, change both of these signs. So that's going to cancel, but now I've got a negative 28 and a negative 18. So that's negative 38. So I'm going to write that as negative 38 over x plus 3. Okay. So then synthetic division is really, really fast. So you're going to make an upside down division. And all you need is the leading coefficients of your, I never can remember, divisor, dividend, whatever the top is. Okay, so in front of x to the third is a 2. So I'm going to write down a 2. In front of 7x squared is a 7, and then a 9, and then a negative 20. Okay, then you look at your denominator. So it's x plus 3, and what's actually going to go on the outside is a negative 3. Okay, so the first step is you're just going to drag this 2 straight down. So that's a 2, and then you're going to multiply. So negative 3 times 2 is negative 6. And then you're going to add the 7 and the negative 6 together. So that's going to be 1. And then you're going to do negative 3 times 1 is negative 3. You're going to add together 9 and negative 3 is 6. You're going to multiply negative 3 times 6 is negative 18. And then you're going to add those together, and there's negative 38. Okay. So this sort of should have some familiarity, that's a hard word for me to say, to the answer that we've already gotten. So the way you're going to rewrite this in a polynomial form is, I started off with x to the third. So it's always going to be one step down from x to the third. So this is going to mean that my first term is x squared. So that's going to be 2x squared. And it's going to go x squared, x, the constant, and then the remainder. Okay, so 2x squared plus 1x plus 6, and then I had a remainder, so this last term is always your remainder, so that was negative 38 over x plus 3. So you'll notice that's exactly the same thing. So just a couple notes. This negative 3 is always what you multiply with. And whatever's in the kind of the upside down division, you always add whatever's in the upside down division. Okay, so let me show you one more, but I'm going to show you with synthetic division because this one is trying to be a little sneaky. Okay, so I'm going to make my upside down division. Okay, and I know that instead of x minus 3, I know I'm going to put a positive 3 on the outside because it's always opposite. Maybe I should write that. up here. Well, that's okay. Now you can't see that. It's always going to be the opposite. And then you want to go in descending order. But this one is really trying to trick us. So in front of x to the fourth is an understood 1. But then what I need is I need an x to the fourth term, an x to the third term, an x squared term, an x term, and then a constant. So even though there isn't one showing, I'm going to have to put in like a 0 placeholder. So here was my x to the fourth. Is there an x to the third? No. So I need to put in a 0. Is there an x squared? No. So I need to put in a 0. Is there an x? No. So I need to put in another 0. And then is there a constant? Yep, 81. So I'm going to put in negative 81. Okay, the first step is to drag down your first term, so it's 1. And then remember, you're going to multiply. So 3 times 1 is 3. Then you're going to add that up. So 0 and 3 is 3. Then I'm going to multiply. 3 times 3 is 9. Add those up. That's 9. 3 times 9 is 27. Okay, I'm going to add those up. That's 27. 3 times 27 is a crazy 81. Well, that's awesome. I'm going to add that up, and that's 0. So that's fantastic because your last term is always your remainder. So this means that it went in perfectly. I have no remainder. But now how do I rewrite this as the polynomial? So I started my highest degree. So my highest degree was a 4. So I know I need to go down 1 step. So I should have an x to the third, an x squared, an x, and then a constant, and sometimes a remainder. Okay, so now I'm just going to take those numbers. So 1 is my x to the third, plus 3 is my x squared, plus 9 is my x term, and then plus 27 is my constant, but I didn't have a remainder. So this is my final answer. Okay, then on the back side of this page is a just keep practicing. So if you will, pause the video, try to do this problem, and then check your work. Okay, so this one did have a remainder of positive 2. Just remember that when you're multiplying, you need to change the sign. That's what most people forget to do. All right, so then, sorry about that, I should have covered that up. Try this problem, pause your video, and then check your work. Okay, this one was much nicer because there was not a remainder, but you can pause and look through those steps. Most of the mistakes are made in here where you should be changing the sign. Oh, which, yeah, I just didn't write it. That should be a negative right there because there's no remainder.